Hello everyone, I'm Vishal. Today I'm going to speak about alternative way for energy usage in various sources applications. So let us study about the introduction. Alternative sources of energy, often referred to as renewable or green energy, are essential components of our evolving energy landscape. These sources provide sustainable alternatives to traditional fossil fuels, which are finite and contribute to environmental degradation through greenhouse gas emissions. Alternative sources of energy harness natural processes and resources to generate power, reducing our reliance on non renewable fuels. Common examples include solar power, wind energy, hydroelectric power, geothermal energy, and biomass, etc. These sources offer numerous environmental, economic, and societal benefits, making them crucial in addressing the challenges of climate and energy sustainability. We have different alternative sources. Let us study each one in detail. Solar energy, wind energy, hydroelectric power, geothermal energy, biomass energy, tidal energy, nuclear energy. Let us go through detail in each of them. Uh, let's study about the solar energy. Solar energy is a renewable energy source that harness the power of the sun's radiation to generate electricity and heat. Here are some key details about solar energy. Solar photovoltaic systems. Solar photovoltaic systems use solar panels to convert sunlight directly into electricity. These panels are typically made of silicon solar cells and are installed on rooftops or in solar farms. Solar thermal systems. Solar thermal systems use sunlight to heat a fluid such as water or a special heat transfer fluid, which can then be used for various applications, including space heating, water heating, and electricity generation through steam turbines. How solar panel work? Solar panels work by utilizing the photovoltaic effect, where sunlight excites electrons in the solar cells, generating an electric current. Inverters are used to convert the direct current DC electricity produced into alternating current AC for use in home and businesses. Environmental benefits. Solar energy is a clean and renewable, producing greenhouse gas emissions or air pollutants. It plays a significant role in mitigating climate change and reducing our dependence on fossil fuels. Wind energy. Wind energy is a renewable energy source that harnesses the kinetic energy of moving air to generate electricity. Here are some key details about wind energy. Wind turbines. Wind energy is captured using wind turbines, which consist of a tower and blades. The tower supports the blades, which are connected to a generator. As the wind blows, it causes the blades to rotate, and this mechanical energy is converted to electricity. Types of wind turbines. There are two primary types of wind turbines: horizontal axis wind turbines and vertical axis wind turbines. Horizontal axis wind turbines are most common and have a three blade design, whereas the vertical axis wind turbines have a unique vertical rotor and are less common but have advantages in some applications. Wind farm installations. Wind turbines are often installed in clusters called wind farms. These farms are strategically located in areas with consistent and strong wind patterns, typically onshore or offshore. Environmental benefits of wind energy include: wind energy is a clean and sustainable power source that produces no greenhouse gas emissions or air pollutants. It plays a crucial role in reducing the carbon footprint and mitigating climate change. Next, we'll go through hydroelectric power. Hydroelectric power, often referred to as hydropower, is a renewable energy source that harnesses the energy of flowing water, typically from rivers or dams, to generate electricity. Here are some key details about hydroelectric power. Types of hydroelectric power plants: runoff river plants. These plants use the natural flow of the river without a large reservoir. They divert a portion of the river's flow through a turbine to generate electricity. River reservoirs plants. These plants involve the construction of a dam to create a reservoir. Water from the reservoir is released through turbines to generate power as needed. How hydroelectric power plants work. In both the types of plants, The kinetic energy of the flowing water is converted into mechanical energy by turbines. These turbines are connected to generators, which then produce electricity as they spin. Storage capacity. Reservoir plants have an advantage of energy storage by controlling the release of water from the reservoir. These plants can generate electricity on demand, making them more flexible in responding to energy needs. Environmental impacts. Hydroelectric power is considered a clean energy source because it produces minimal greenhouse gas emissions. However, dam construction can have ecological impacts, including altering river ecosystems and potentially displacing local communities. Next, we have biomass energy. Biomass energy is a renewable energy source that is derived from organic materials such as plants, agriculture, and forestry residues, and even municipal and solid waste. Here are some key details about biomass energy. Biomass sources. Biomass can be obtained from a wide variety of sources, including wood and wood residues, agricultural crops and residues, such as crop waste and corn stalk, energy crops like switchgrass and miscanthus, organic waste materials, including sewage, sludge, and landfill gas algae and aquatic plants. Conversion methods. Biomass can be generated through several conversion methods, including combustion, burning biomass to produce heat or electricity, gasification, converting biomass into a gas, which can be used for electricity generation or as a fuel, anaerobic digestion, breaking down organic materials in the absence of oxygen to produce biogas, for energy, pyrolysis, heating biomass in the absence of oxygen to produce biooil, biochar, and syngas. Environmental benefits of biomass energy are: biomass energy is considered carbon neutral because the carbon dioxide emitted during combustion or gasification is a part of the carbon cycle. It can help reduce greenhouse gas emissions, such as long as biomass is sustainably managed. Next, we'll go through tidal energy. Tidal energy is a renewable energy source that harnesses the power of the tides, which are caused by the gravitational pull of the moon and sun on the Earth's oceans. Here are some key details about the tidal energy. Tidal range and energy potential. Tidal energy is generated by the rise and fall of sea levels, known as the tidal range. The energy potential of tidal tides is significant as they are predictable and occur twice a day in most coastal regions. Types of tidal energy. Tidal system stream systems. These systems use the kinetic energy of moving water, much like underwater wind turbines, to generate electricity. Tidal stream turbines are typically installed on the seabed. Tidal range systems. Tidal range systems use the difference in water levels between high and low tides to generate electricity. These systems include tidal range barrage, which are large dam built across estuaries or tidal basins, and tidal lagoon systems. Environmental impact. Tidal energy is considered as a clean energy source with a minimal greenhouse gas emissions. However, the construction of tidal range barrages and lagoons can have environmental and ecological impacts, such as altering water flow and affecting ecosystems. Nuclear energy. Nuclear energy is a form of a power generated through the controlled release of energy from atomic nuclei, typically in the form of nuclear fission. Here are some key details about nuclear energy. Nuclear fission. Nuclear energy is primarily produced through a process called nuclear fission, in which the nucleus of an atom is split into two smaller nuclei, releasing a significant amount of energy in the form of heat. Next, we have fuel. The most common nuclear fuel used is uranium 235, U-235, although plutonium 239, Pu-239, and other fissile materials can also be used. These fuels are usually enriched to increase the concentration of fissile isotopes. Nuclear reactors. Nuclear reactors are the facilities where controlled nuclear fission takes place. These reactors are designed to maintain a self sustaining chain reaction and produce heat. Heat generation. In a nuclear reactor, the heat generated from nuclear fission reactions is used to produce steam from water. The steam then drives a turbine connected to a generator producing electricity. Next, we have conclusion. In conclusion, alternative sources of energy represent a pivotal and sustainable shift in our global energy landscape. These sources, including solar, wind, hydroelectric power, biomass, tidal, and nuclear energy, offers a diverse solutions to mitigate climate change, reduce, reducing environmental impact, and secure our energy future. Solar and wind energy harness the power of natural elements, providing clean, abundant, and rapidly advancing technologies. Hydroelectric power taps into the predictable strength of tides and rivers, while biomass energy reuses organic materials, offering an adaptable and efficient energy source. Tidal energy, though less common, shows promise in regions with strong tidal currents, and nuclear energy remains a controversial yet powerful contributor to low carbon electricity. Thank you, one and all.